participants. So in this topic, we'll talk about problem solving, but we'll be focusing on inductive and deductive reasoning. So in this lesson, most occupations require good solving skills, for instance, architects and engineers. Most solve many complicated problems at the design and construct modern buildings that are aesthetically pleasing, function, and that meet stringent safety requirements. Two goals are to help you become a better problem solver and to demonstrate that problem solving can be an enjoyable experience. Inductive reasoning is a type of reasoning that forms a conclusion based on the examination of specific examples. So, inductive reasoning can be based on an observation, and it can also be our valid guess. It also makes broad generalization from a specific observation. So, that the conclusion that as formed in inductive reasoning is called conjecture. An idea that may or may not be correct. In this topic of inductive reasoning, meron siyang possible na maging tama or mali ang ating conclusion dahil bumabase lamang ito sa ating observation. Kaya nakadepende ito kung paano mo inoobserbahan ang isang problem. Here are the examples. So we will use inductive reasoning to predict the next number in each of the following list. So example, 3 followed by 6, 9, 12. So ano nga ba ang kasunod niya? So hanapin natin kung ano ang kasunod na number ng 12. So kung nakikita nyo, ang mga example natin ay even numbers. So ang mga number na ito ay divisible by 3 based sa ating observation. So nag-start tayo ng 3 followed by 6, 9, and 12. So therefore, conclude that the next number is 15. So dito sa inductive reasoning, we use a pattern based sa ating observations na nagbibigay sa atin ng paraan para magkaroon ng general conclusion. So dito sa inductive, unlike sa deductive reasoning, wala tayong sinusunod na basic format para mag-come up ng isang conclusion. Basta mahanap lang natin ang tamang conclusion. So that the most certainly fits pattern that allow us to forecast and build a cause and effect analysis. So we use inductive reasoning to make a conjecture. So ito yung mga paraan. First, pick a number. Second, multiply it by 8. Third, add 6 to the product. 4, divide the sum by 2. Last, subtract 3. So we'll carry out the process for a few distinct numbers. So let's apply inductive reasoning to formulate a hypothesis regarding the correlation between the size of the numbers and the original number. Next, the process would be in the following. So magbibigay tayo ng original number, halimbawa 5. So multiply by 8, 5 times 5 equals 40. So add 6, so 40 plus 6 equals 46. So divide by 2, so 46 divide 2 equals 33. So last natin na paraan is subtract 3, so 23 minus 3 equals 20. So that's the final answer. So kung gagamit tayo ng 5 equals 20, ganun din sa 6 magiging 24. So sa 10 naman is magiging 40 and sa 100 is magiging 400. So the resulting number is 4 times to the original number. Thus we hypothesize that using the specified process result in a number that is 4 times the initial number or original. So our next topic is about deductive reasoning. So deductive reasoning is a distinguished from inductive reasoning in that it is the process of reaching a conclusion by applying general principles and procedures. It's the process of reaching a conclusion by applying general assumptions, procedures, or principles. So use deductive reasoning to establish a conjecture. So pick a number, multiply the number by 8, add 6 to the product, divide the sum by 2, and subtract. So ito yung solution natin. Let n represent the original number. So first is multiply the number 8. So 8n, pangalawa, add 6 to the product. So 8n plus 6. So ang pangatlo natin is divide the sum by 2. So 8n plus 6 equals 4n plus 3. Bakit? 8 divided by 2 equals 4n, and 6 divided by 2 equals 3. Kaya naging 4n plus 3. So last is subtract 3. So 4n plus 3 minus 3 equals 4n. So 4n plus 3 equals 7. So minus 3 kaya 4n. So we started with n and ended with 4n, the procedure given in this example. It produced a number that is 4 times the original number.
And especially to you, sir. So now I will discuss the assigned topic. Can puzzles an introduction. When you first introduce any new puzzle, focus on elements common to all problem solving, finding an entry point. Model search for a starting place. Say openly that you are deliberately looking for an easy place to start. Some people like the term strategically lazy. Some prefer to say taking a moment to think so we don't have to work so hard later. Keeping track, be the scribe. Modeling for students how to keep track of what they do know. You'll see example of what this means below. Experimenting but not guessing. Show how never to guess at what they don't know. The examples below will help make this clear it. So let's proceed our basic puzzle solution strategy. Draw a grid showing the right order for the tiles to keep track of where the tiles should go when you're finished. Draw a grid on a separate sheet of paper. Mark each square of the grid with numbers reflecting the order that the tiles will be in when you have solved the puzzle. In most cases, you will need to put the tiles in numerical order, starting with number 1 at the top left corner and moving down each row left to right. Many slide puzzles already have numbered tiles, which makes it easier to know the order they belong in. Slide puzzle with image may not have numbers on the tiles. In this case, assign numbers to the tiles. For example, if a tile has the top left corner of a face, make that tile number 1 on your grid and continue numbering along the top row. So, thank you.
Assalamualaikum warahmatullahi wabarakatuh. Good day everyone, especially to you sir. So today I will discuss my assigned topic, which is inductive reasoning and deductive reasoning. So inductive reasoning is the act of making generalized conclusions based off specific scenarios. Examples: determining when you should leave for work based on traffic patterns. Rolling out a new accounting process based on the way users interact with the software. So deciding on the interactive plans based on an employee survey. changing a meeting time or format based on participant energy levels. So, let us proceed to deductive reasoning. So, ano nga ba ang deductive reasoning? So, deductive reasoning is the act of backing up a generalized statement with specific scenarios. Examples: developing a marketing plan that will be effective for a specific audience. So, designing the floor plan and layout a shop to maximize sales, determining the most efficient ways to communicate with clients, planning out a budget to get the highest output from your investments. So, inductive reasoning involves starting from specific premises and forming a general conclusion, while deductive reasoning involves using general premises to form. So, let us proceed to magic squares. A magic square of order n is an arrangement of numbers in a square such that the sum of the n numbers in each row, column, and diagonal is the same number. The magic square below has order 3, and the sum of the numbers in each row, column, and diagonals is 15. Use deductive reasoning to show to the following procedure. Always procedure a number that is equal to the original number. So, procedure: pick a number, multiply the number by 6 and add 8, divide the sum by 2, subtract twice the original number and subtract 4. Use deductive reasoning to show that the following procedure always procedure the number 5. So next is each successive numbers is 3 larger than the preceding number. Thus we predict that the most probable next number in the list is 3 larger than 15, which is 18. And the first two numbers differ by 2. The second and the third numbers differ by 3. It appears that the difference between any two numbers is always 1 more than the preceding half difference. Since 10 and 15 differ by 5, we predict that the next number in the list will be 6 larger than 15, which is 21. Inductive reasoning is not used just to predict the next number in a list. We can also use inductive reasoning to make conjecture about an procedure. So, example, consider the following procedure. Pick a number, multiply the number by 8, add 6 to the product, divide the sum by 2, and subtract 3. Complete the above procedure for several different numbers. Use inductive reasoning to make a conjecture about the relationship between the size of the resulting number and the size of the original number. So, if the length of a pendulum quadrupled, what happens to its period? So, solution is, in the table on the previous page, each pendulum has a period that the square root of its length. So, we conjecture that pendulum with length of 25 units will have period of 5 herbits. So, in the table, and pendulum with a length of 4 units has period that is twice that of a pendulum with a length of 1 unit. A pendulum with a length of 16 units has period that is twice that of pendulum with length of 4 units. That's all. Thank you.
So, Assalamualaikum warahmatullahi ta'ala wabarakatuhu. I am Nuraina Karimayo and this is my report topic. So, allow me to discuss about the historical note about George Polya. So, after a brief stay at Brown University, George Polya moved to Transford University in 1942 and taught there until his retirement. While at Stanford, he published 10 books and a new number of articles for mathematics. journals. Of the books Polya published, How to Solve It, 1945, is one of his best known. In this book, Polya outlines a strategy for solving problems from virtually and discipline. So, sabi nga nila, a great discovery solves a great problem, but there is a grain of discovery in the solution of any problem. So, your problem may be modest, but if it challenges your curiosity and brings into play your inventive faculties, and if you solve it by your own means, you experience the tension and enjoy the triumph of discovery. So, section 3.3, problem solving strategies. George Polya's problem solving strategy. Ancient mathematicians such as Euclid and Pappus were interested in solving mathematical problems, but they were also interested in heuristics, the study of the methods and rules of discovery and invention. It is 17th century. The mathematician and philosopher René Descartes in 1586 to 1650 contributed to the field of heuristics. And he tried to develop a universal problem-solving method. Although he did not achieve this goal, he did publish some of his ideas in rules for the direction of the mind, and his better known work, Discours de la Méthode. And another mathematician and philosopher, Gottfried Wilhelm Leibniz in 1646 to 1716. So, planned to write a book on heuristic titled Art of Invention. Of the problem-solving process, Leibniz wrote wrote nothing is more important than to see the sources of invention, which are, in my opinion, more interesting than the inventions themselves. And one of the foremost recent mathematicians to make a study of problem solving was George Polya, 1887 to 1985. He was born Hungary and moved to the United States in 1940. The basic problem solving strategy that Polya advocated consisted of the following four steps. So, this is Polya's four-step problem-solving strategy. So, we have number 1, understand the problem. Number 2, devise a plan. And number 3, carry out the plan. Number 4, review the solution. So, understand the problem, can you restate the problem in your own words? And can you determine what is known about these types of problem? In their missing information that, if known, would allow to solve the problem? Is there extraneous information that is not needed to solve the problem? And for the last is, what is the goal? The second one is devise a plan. Make a list of the known information. Make a list of information that is needed. Draw a diagram. Make an organized list that shows all the possibilities. Make a table or a chart. Work backwards. Try to solve a similar but simpler problem. Look for a pattern. Write an equation. If necessary, define what each variable a variable represents, perform an experiment, guess at a solution, and then check your result. For carry out the plan, work carefully. Keep an accurate and neat record of all your attempts. Realize that some of your initial plans will not work and that you may have to devise another plan or modify your existing plan. For the review the solution, ensure the solution is consistent with the facts of the problem. Interpret the solution in the context of the problem. Ask your whether there are generalization of the solution that apply to other problems. And this is example 1. Apply Polly's strategy. So as you can see, consider the map shown in figure 3.2. Allison wishes walk along the streets from point A to point B. So, take note. Polly's first step are deceptively simple to become a good problem solver, and it helps to examine each these steps and determine what is involved. So, for this example 1, meron po tayong First Avenue, Second Avenue, Third Avenue, and Fourth Avenue. This is the solution of George Polias. So, understand the problem. We will not to able to answer the question if Allison retract her path of travel away from point B. Thus, we assume that on a direct route, she always travels along a street, a direction that gets her closer for point B. And devise a plan. The map in figure 3.2 has many extraneous details. Thus, we make a diagram that allow us to concentrate on the essential information. See the figure at the left. Because there are many roads, we consider the similar but simpler diagram shown below. The number at each street interaction represent the number of roads from point A to that particular intersection. And look for patterns. It appears that the number of roads to an intersection is the sum of the number of roads to the adjustment intersection of its left and the number of roads to the intersection directly above. For instance, the number of roads to the intersection labeled 6. 6 is the sum of the number roads of the intersection to its left, which is 3, and the number of roads to the intersection directly above, which is also 3. And carry out the plan using the pattern discovered above. We see from the figure at the left that the number of roads from point A to point B is. And review the solution. Ask yourself whether a result for 35 seems reasonable. If you were required to draw each road, could you devise a scheme that would enable to draw each road without missing a road of duplicate a road? And This is example to apply Polia's strategy. Make an organized list. A baseball team won 2 out of their last 4 games. In how many different orders? Could they have 2 wins and 2 losses in 4 games? And this is the solution. Understand the problem. There are many different orders. The team may have won 2 straight games and lost the last 2. So, as you can see naman sa cross parenthesis is uh, 2 win and 2 loss. Or maybe they lost the first 2 games and won the last 2. In the cross parenthesis, 2 loss and 2 wins. Of course, there are other possibilities such as win-loss, win-loss. And for devise a plan, we will make an organized list of all the possible orders. An organized list, a list that is produced using a system that ensures that each of the different orders will be listed once and only once. And carry out the plan. Each entry in our list must contain 2 wins and 2 losses. We will use a strategy that makes sure each order is considered with no duplication. One such strategy is to always write our wins unless doing so will produce too many wins or a duplicate of one of the previous orders. If it is not possible to write wins, then and only that do we write and lose. This strategy produced the 6 different orders shown below. And for the 1 to 6, yan po yung 6 different orders shown below. For the review the solution, we have made an organized list. The list has no duplicates and the list considers all possibilities. So we are confident that there are 6 different orders in which a baseball team can win exactly 2 out of 4 games. For the example 3, solve a similar but simpler problem in a basketball league consisting of 10 teams. Each team plays each of the other teams exactly 3 times. How many league games will be played? And understand the problem. There are 10 teams in the league and each team plays exactly 3 games against each of the other teams. And devise a plan. Try the strategy of working a similar but simpler problem. For the carry out the plan using the process developed above, we see that 10 teams can play each other once in a total of 10.9 divide 2 equals 45 games. For the review the solution, we could check our work by making a diagram that includes all 10 teams represented by dots labeled A, B, C, D, E, F, G, H, I, and J, and also the J. Because this diagram will be somewhat complicated, let's try the methods of making an organized list. And items, the second row has 8 items. The third row has 7 items, and so does 10 teams required. So 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 is equal 45 games if each team plays every other team once, and 45.3 equals 135 games if each team plays exactly the games against each opponent. For the last examples, apply police strategy. Make a table and look for a pattern. So determine a digit 100 placed to the right of the decimal point in the decimal representation. Understand the problem. Express the function 725 as a decimal and look for a pattern that will enable us to determine the digit 100 places to the right of the decimal point. And for the divisa plan, dividing 27 into 7 by long division or by using a calculator produces the decimal 2.25. Since the decimal representation repeats the digits to 259 over and over forever, we know that the digit located 100 places to the right of the decimal point is either a 2 and 5 or a 9. A table may help us to see a pattern and enable us to determine which ones of these digits. And for carry out the plan, only in column 3 is each of the decimal digit location evinced divisibly by 3. From this pattern, we can tell that the 99th decimal digit, because 99 is evenly divisible by 3, must be a 9, since 2 always follows a 9 in the pattern. That 100 decimal digit must be a 2. For review the solution, the above table illustrates additional patterns. For instance, if each of the location numbers in column 1 is divided by 3, a remainder of 1 is produced. If each of the location numbers in column 2 is divided by a 3, a remainder of is produced. Thus we can find the decimal digit in any location by dividing the location number by 3 and examining the remainder. For instance, to find the digit in the 3,200 decimal place for 7 dividing to 27, merely divide 3,200 by 3 and examine the remainder, which is 2. Thus, the digit 3,200 places to the right of the decimal point is 5. So take note, guys. This is the last part. The strategy of a working similar but simpler problem is an important problem-solving strategy that can be used to solve many problems. And that's all. Thank you. Thank you for watching, and also thank you for listening.
Assalamualaikum warahmatullahi wabarakatuh. And my name is Abdul Muhammad. And this our assigned topic today is all about mathematical prodigy and apply Polias strategy. And the first assigned topic, mathematical prodigy. Carl Friedrich Gauss and was scientist and mathematician, his word incoming passed. Several disciplines, including number theory, analyzing astronomy, and optics. He is known for having shown mathematical prowess as early as age 3 is reported that soon after Gauss entered elementary school, his teacher assigned the problem of finding the sum of the first 100 natural number. Gauss was able to determine the sum in a matter of a few seconds. The following solution show the thought process he used. The first step, understand the problem. The sum of the first 100 natural numbers is represented by 1 plus 2 plus 3 plus point plus 98 plus 99 plus 100. Next step, devise a plan. Adding the first 100 natural number from left to right would be the time consuming. Gauss considered another method. He added 1 and 100 produced 101. He noticed that 2 and 99 have a sum of 101. And that 3, 98 have a sum of 101. Thus, the 100 numbers could be thought of as 50 pair. It's with a sum of 101. Carry out the plan to find the sum of the pair. It's with sum of 101. Gauss computed 50, 101 and arrived at 5050 as the solution. Next, review the solution. Because the added in a addition problem can be placed in any order without changing the sum, Gauss was confident that had the correct solution. An extension, the sum. 1 plus 2, 2 plus 3, 3 plus point plus bracket n minus 2 bracket right bracket naman plus n bracket n minus 1 and bracket plus n can be found using the following formula. A summative formula for the first n natural number. Example, 1 plus 2, 2 plus 3, 3 plus point plus n minus 2 plus n minus 1 plus n equal to n bracket n plus 1 bracket 2. Some problems can be solved by making guess and checking your first few. Guessing may not produce a solution but quit. Often they will provide additional information that will lead to a solution. For next assigned topic, apply Polia's strategy. Guess and check. The produce of the age and years of 3 teenager is 4,590. None of the 10 are the same age. What are the age of the teenager? The first step, solution. Understand the problem. We need to determine 3 distance counting number. From the list 13.15 15.16.17.18 and 19 point that have produce of 4,590. And two step, devise a plan. If we represent the edge by x point, y point, and g, then xyg minus 4590. We are unable to solve this equation, but we notice that 4590 is in a zero. Hence, 4590 has a factor of 2 and factor of 5, which means that less one of the number we check must be an even number, and at least one number must have 5 as factor. The only number in our list that have 5 as a factor is 15. Thus 15 is one of the number, and at least one of the other number must be an even number. At this point, we try to solve by using and checking. And 3-step out the plan. 15 slash CDOT 16 slash CDOT 18 equal to 4390. Notice produce is too small. For next, 50 slash CDOT 16 CDOT 19 equal to 4560. This produce is too small din. For next, 15 slash CDOT 17 CDOT 18 equal to 4590. Yes, this is the correct product. The age of the teenager are the 15.17 and 18. Review the solution because 15 slash CDO to 17 CDO to 18 minus equal to 4590, and each of the edge representing that edge of a teenager. We know our solution is correct. None of the number 18.14.16 and 19 is a factor divisor of 4590.